Good afternoon, everyone. We're going to give another minute or two for people to sign in before we get started. Some quick housekeeping things to note. If you have a question during our presentation, please use the question and answer window. If you hover over your screen, it should appear at the bottom center. If you enter questions into the chat window, we might miss them. So we do appreciate using that question and answer window so that we can catch all your questions and try to get them answered during our presentation. The presentation is being recorded and will be available at our website after we are completed. And also, all attendees will get a certificate of attendance from us. If you need AIA or IECC credits, send us an email once you receive that certificate and we'll be sure to turn in those credits for you. We'll get started in just another minute. All right, we're going to go ahead and get started. Welcome everyone to our SEDAC Energy Code presentation on key items for site inspections based on 2018 IECC residential provisions. My name is Sean Maurer. I'm a mechanical engineer at the Smart Energy Design Assistance Center. Joining me today is Ryan Siegel, my colleague, another energy engineer in our office. The things we're going to cover today, we're going to try to understand the site inspection practices for residential buildings. We're going to learn which measures generally are not meeting the energy code requirements during the construction phase. And we're going to understand or demonstrate how to comply with energy code requirements at the site inspection stage of the construction process. The Smart Energy Design Assistance Center is an applied research program at the University of Illinois. Our mission is to reduce the energy footprint of Illinois and beyond. As part of that, this energy codes program is a key component. Training for this program is sponsored by the Illinois State Energy Office. We're proud to work with them. Our Energy Codes training program provides technical support through a email address at energycode@sedac.org. We also have a 1-800 number that you can call for quick assistance. We do prefer the use of that email address as it gives us time to research your question and give you an accurate answer. But that phone number is also available. We also have a number of online resources at our website, sedac.org/energycode-code. All our previous workshops and webinars are recorded and stored on that website. We also have online on-demand training modules that you can take at your own pace. As you take those modules, when you complete them, you'll get a completion certificate, so you can use those for continuing education credits as well. Again, I'd like to note during our presentation today, if you have a question, please use the Q&A window to enter that so that we can be sure to answer your question as we go along. At our website, this is what that page for those technical resources looks like. You'll be able to access previous workshops, webinars, courses, and our technical support information. We also have links to the energy codes, both at the IECC website, the Illinois amendments, and the Chicago codes. We also have a link to the Chicago codes with the IECC, or with the ICC now that those are available as well. So Title 14N is a published IECC document now. And finding these links on our website is a lot easier than trying to record these links. So this is one component of a series of presentations on improving compliance with the energy code. We're covering residential site inspection today, and we'll be doing another session on it in March. Upcoming, we also have commercial plan review and commercial site inspections, and we're hosting a couple of code panel discussions where we have code officials and our engineers to answer questions and cover the energy code in detail. We also have a series of lunchtime webinars. We'll be covering the commercial envelope next during our next webinar. And again, that's going to be over key items for plan review and site inspections. We also have case studies and lessons learned coming up, commercial lighting, and commercial HVAC. So when does the code apply to updates to buildings? If you have an existing building, the 2015 International Residential Code, Chapter 1, Section 105 contains exemptions from when a building permit is required. You have to apply for a permit for the energy code to trigger for its requirements. So below we've listed some examples from that residential code of things that are exempt from permit. They will vary somewhat with your local building office, so check with them for a detailed list to make sure. The next question is, are you in a residential building? A detached one-family or two-family dwelling, or any building that is 3 stories or less above grade, or 4 stories and less in Chicago, that contains multiple dwelling units where occupants reside on a primarily permanent basis. So this is going to be apartment-style buildings, low-rise, townhomes, single-family homes. If you have a high-rise apartment building where you're greater than 3 stories, or in Chicago greater than 4 stories, and that's going to fall under the commercial provisions. And I will now hand it over to Ryan to cover the first sections of our site inspections.
Well, thank you, Sean. As Sean noted, I am Ryan Siegel, and the code calls out at least 5 different inspections or inspection times. We understand that this is part of a much broader inspection plan that construction has, and so frequently these are carried out during some of the other inspections that may be called for in the residential code. The energy code calls out 5 different ones from meeting with code officials. They noted that it's not uncommon for there to be 10 or even as many as 20 different site inspections for various aspects. So with the energy code, this is beginning with the footings and foundations. So we want to make sure that we start from the bottom up as we go through. And so here it talks a little bit about some of the items. We're going to go through these in greater detail. But along with this, we also note here the illustration on the right is showing a vented crawl space. So the footing and foundation may have very little in the way of inspections for vented crawl spaces, but noting here, because the flooring insulation and the like for that thermal envelope would be included during subsequent inspections. So just being aware. SEDAC is also presently working on some materials that can aid in plan review and inspection communication between the design professionals as well as the code officials. So by using some of these tools, that can help smooth some of the workflow and improve the speed at which some of these can occur. This also, as you note here, enables the design professionals or the design team to designate what values they've designed to, the reviewer to verify it, and then the inspector to verify that it matches the design. So this kind of gives a good check through from beginning to end. So being aware that some of these tools are out there, and again, check with your local building official to see if they may already have some tools, because we understand that the tools that can aid in the communication and can expedite plan review are very beneficial for the entire project team. So as far as insulation depth, this is an illustration that comes from ResCheck, and we like to bring this forward because this is fairly detailed as far as an illustration between what is your total wall height versus how much of this is below grade, and then where you're measuring your depth of insulation. And so that depth of insulation, depending on the application, could be from the top of the wall. It could be from the level of the ground. So again, that depends on where that insulation is and what insulation that is. So the rim board, we also note here that that little rim board is also part of the above grade wall. So we're getting into footings and foundations. First, we're needing to check that the location matches the design. Is the insulation on the interior, or is it insulated from the exterior? And similarly, is this cavity insulation or continuous insulation? And we note that continuous insulation means that it does not have any thermal bridges other than fasteners or service openings. So in order to qualify as continuous, you can't have framing members breaking that up. And also, we need to make sure that we're aware as far as where our thermal envelope is. So in this case here on the right, we show interior basement walls. And with those interior basement walls, they're insulated here if the event that we are doing a crawl space, depending on if that's vented or not, may depend on where that insulation is. In this basement area, even if this is an unconditioned basement, we still would have to insulate the walls if we're not going to insulate the floor above, because we need that full boundary of the thermal envelope. Once we've identified where our insulation is, next is to check what the R value is. And is it the proper quantity? Does that match our design? And something to be very cognizant of here is the insulation R value changes with compressible insulation, whether that's fiberglass or cellulose or denim or any number of other insulations. So just because it states R19 on the face doesn't necessarily mean it's a full R19, particularly if it's compressed. So once we've identified, and figured our R value, what it is, next is checking for the thickness. And as I noted earlier, insulation, if you compress it, the R value will change, and the R value will decrease, the total R value will decrease as the insulation is compressed. Here on the left, we see some insulation bats where it says R19 on the label, and we notice here it says it's 6 1/4 inches thick. Well, a 2x6 wall is not actually 6 1/4 inches thick, it's only 5 1/2. And so this particular product in the cut sheet notes that if you place this insulation product that states it's for 2x6 walls into a 5 1/2 inch cavity, which would be a typical 2x6, it only is an R18. So again, noting here, just because it says it on the label doesn't mean that's what the R value is as installed. Foam insulations tend to have much less issues with compression. However, that's not to say they can't be compressed. And one of the big issues here is if we do have insulation that is not an air barrier and is air permeable, the insulation rating is only maximally effective when it's bounded on all 6 sides. So top, bottom, the 2 sides, and front and back. So we need to have it bounded. If we do not bound the insulation on all 6 sides, air currents can develop within this air permeable insulation, which will degrade its performance. So again, understanding what you're getting as you're doing it. So for footings and foundations, here we're going to need to check as far as does it go down far enough per the specification, whether that's 2 foot or 4 foot. Code also calls in some areas to have that wall insulated all the way down to at least 10 feet. We will note there is an Illinois amendment on some of those where it's to within 6 inches of the floor. Some of that may be to aid in moisture evaporation and prevention of saturation. Code also does allow for part of the insulation to be placed in a horizontal plane. So we'll have a vertical portion and then a horizontal portion. The sum total of the height and the length that it comes out would need to meet the specification, be that 2 foot, 4 foot, or whatever the other, whatever the specification would call for. So as far as protecting our insulation, once we install our insulation, we need to protect it from many different aspects. Some of this can be compression, physical damage, ultraviolet light, or fire. There have been some cases where insulated exterior assemblies have resulted in some rather dramatic fires due to improper protection of the insulation from fire. And part of this physical protection is if you are going to use some of the insulation on a horizontal, first making sure that's not a compressible insulation, and second that it's at least 10 inches below ground, and that provides some physical protection. So in case someone goes to perhaps plant a plant beside the foundation, there's less likelihood that they're going to end up digging into that insulation. So protecting that insulation is critical from our long-term performance perspective. So something else the code calls for is making sure that we're protecting it from insects and other animals. So we want to make sure that if we use an insulation that insects may wish to consume, that we've provided protection for that. So once we've gotten through our footing and foundation, next up is framing and rough-in. So now that we're getting above ground for our insulations. And so this can be performed in a couple of different ways. This can be performed as 2 different inspections. We have seen some locales where they prefer to do a framing and structural and air sealing inspection before the insulation is installed, and then do an insulation inspection at a later date. It also could be a single inspection. Probably a good practice is to have these as separate inspections, so that way it's easier to identify issues with air sealing before they get covered up by insulation. So again, do check with your local building department as far as the order and locations in which they prefer to occur. Next up, needing to verify that we do have, these are several different aspects that are checked as part of the framing and rough-in inspection. Again, these could be done as a series of different inspections throughout the building process. So we'll touch more on this as we go. So similar for our footing and foundations, we need to check the types of insulations that are used. It's not uncommon where, as part of building design, different locations use different types of insulation. Here we see a building where they've decided to use stone wool product on the outside for exterior insulation, and this could be paired with fiberglass attic insulation. So that's not uncommon to see different types of insulation, but we want to make sure that the insulation that's installed is matching what the design intent was. You know, if they called for stone wool in the attic and then fiberglass was installed, that could impact the design, particularly as those two insulations frequently have different R values per inch. So if you install the same 8 inches that was called for in the specification, but it's a different material, that R value may not match. We also note here that if the insulation is supposed to be the vapor barrier and the insulation changes, that could have a dramatic impact. Or conversely, if the insulation is not supposed to be a vapor barrier, but the insulation that is installed is a vapor barrier, this could potentially set up an issue where you have double vapor barriers, which is a bad thing to occur because you can end up with moisture trapped between the two. So, next up is, once we've verified our insulation is correct, next is checking for the R value. And understanding that, does this match the design? Again, if it's higher than the design, that's typically perfectly acceptable under most circumstances, because all that will do is provide some extra or reduced energy consumption. Proper depth of insulation. For blown-in insulations, then there needs to be proper depth gauges. And the code calls out that these have to be placed at least every 300 square feet at a minimum, and they need to be affixed to trusses or joists. That center picture there, you can see there's an arrow indicating that that depth gauge was improperly installed, as it was not affixed to the truss or joist. This can be particularly problematic here in the picture on the left, showing where this depth gauge was improperly installed and may have was allowed to sag, such that the insulation depth marker indicates 18 inches off the bottom reference, whereas a tape measure found that mark is actually only 15.5 inches off the mark. So that means that this marker has sagged by 2.5 inches, which would indicate that there, if you just read the tag and it was blown up to an R49, there's actually not a full R49 there, because there's 2.5 inches less insulation that was actually installed. So making sure that the 0 is actually correct. For locations, if you do use spray foam, you do have to provide a signed insulation certificate that indicates the thickness and the R value. So this needs to be a signed product, or a signed document. Typically this would either be located either wherever the utility certificate is, typically by the mechanical room, or perhaps at the opening to the location. So right by the attic hatch would be a fine place for this, for attic insulation. So for blown-in products, it does require a pretty decent list as far as specifying the initial installed thickness, what the settled thickness is, the settled R value, install density, the coverage area, and the number of bags has to be put on the certificate. So that's a fair number of aspects that you need to make sure. And again, locating these in a conspicuous location. So, also, as part of framing and rough-in, needing to check, did we put it in the right location? Attics, we've seen several attics where they are insulated along the roof and commonly along the floor. And so making sure that the location is wherever it was stated to be. This could dramatically change energy consumption of the building, where if the attic was not designed to be conditioned at all, and the insulation was designed to be on the floor of the attic, and it was later moved to the roof, and so the attic becomes conditioned or potentially conditionable space in the future, that could have an impact. Also, continuous versus cavity insulation. Both of these here depicted are cavity insulation because I do have structural members showing, and the insulation is not continuous across the structural members. But this may also be continuous on the outside of a roof. A little less common to see that in residential, to see above roof deck insulation, but it is quite possible. And we may see that going into the future. That may become more common. Next is checking, do we have the proper installation? So now that we have, do we have the right insulation? Have we installed it properly? Need to make sure, again, that we've filled the full cavity and that it's uncompressed. Here again, noting that for air permeable insulation, do we have it bounded on all 6 sides? This can be particularly problematic for basement walls, which may just be furred out in front of a concrete wall, making sure that you have actually bounded the back side of that insulation so that you don't end up with a potential air current being there. Something else that is a little difficult to see, but here is being aware as far as the vapor retarder. Here on the left, we see a craft face paper vapor retarder, and being aware, is this stapled to the side of the 2x4s or 2x6s, or is it stapled to the face of the framing members? If you side staple the insulation, first you need to check with the manufacturer as far as, is that proper? Some manufacturers allow for side stapling, others do not. However, one problem with there's a few problems with side stapling. One is you have the potential air current because now the insulation right by the framing now has a pocket of air. So you could have air currents that develop in these spaces. The second is that vapor retarder no longer comes and overlaps with one another. So your vapor retarder is no longer continuous. So that's another issue if you side staple the bat insulations. So something else that checking for is it properly installed around obstructions? Commonly, obstructions would be electrical wiring or plumbing. And so making sure that for bat products, was it properly split and installed around the obstruction, or depending on the insulation, it may just be sliced so that it will fit around the obstruction and meet back on the other side. As far as fenestration, so moving over to fenestration, this would be during framing and rough-in. Again, as we mentioned earlier, air barrier, the fenestration is part of this. So we'll in here on the right, we see some foam being installed around a window. We need to make sure that we don't fill this cavity completely with foam, but we'll talk a little bit more about this later. So as far as when we're checking our fenestration, first is checking the U factor and have we matched the design. Again, in this case, if we have a lower U factor, since U is transmission of energy, whereas R is resistant to transfer of energy. So a lower U factor is acceptable for this. If it's dramatically different, this may have an impact on the equipment sizing, which could cause a challenge with this. For most residential construction, this is as simple as just looking at the tag, the NFRC label that's normally affixed to the windows. Commercial has a few more issues, particularly for site built, but we don't see that too much in residential. So the next thing is solar heat gain coefficient, making sure that this matches the design. Solar heat gain can be used to a design's advantage, particularly if you're dealing in passive house construction. So being aware of this and saying, does it match the design as far as that? Because solar heat gain can have a dramatic impact as far as HVAC loads. So as far as checking that we have installed the fenestration properly, this one, making sure that was there proper space for air sealing around the window or door. Windows and doors should not be perfectly tight to their openings because we need to make sure that there is room for that air sealing detailing to be installed. Also, on the outside, making sure that this bottom flange is not caulked because in the event that water does enter this space behind the window flange, we need to make sure that it has a way to get out so the assembly can dry. And here on the left, you can see where they're showing the bottom flange has not been caulked. And on the right, you can see where they've caulked the top, and then there's a second air seal. So the bead of caulk is our water seal or our vapor seal to the outside of this window assembly. And then on the inside, you'll see there's a piece of backer rod and then caulk. So that is our air seal. The air seal on the interior being continuous all the way around on all four sides. So this is where that between the water seal and the air seal, this allows for a chamber where in the event that any water does get past that water seal, it can enter this chamber, work its way around to the bottom of the window, and then make its way out of the assembly. Something else that this chamber does provide for is because this chamber is going to be at a very similar air pressure to the outside, this water seal has very little air pressure across it. So there's going to be much less chance due to lower driving force of water penetrating that seal. So again, that interior seal we need to make sure is continuous on all four sides. The exterior is going to be continuous on three sides, top and the two sides. So once we've got proper installation and we do have our gaps and seals, making sure do we have proper air leakage controls? Were they damaged during installation? Seals and brushes. If a window's not hung square, it may be a little more obvious as far as are the locks engaging properly. It's not uncommon where you'll see windows that have not quite been installed correctly and the window locks are not able to engage. The air leakage testing is done with locks engaged. So if you're not able to engage the lock properly, the window is not going to be able to meet the air sealing rating that it has. So That kind of covers our footing and foundation and framing and rough ends. So with that, let's pause a minute for some poll questions, and also if we have any questions that have come in, we can answer some of those. So our first poll question is, can continuous insulation have thermal bridges other than fasteners and service openings? No, yes, or maybe. Second is, what does insulation need protection against? You can choose more than one of these: compression, wind, ultraviolet, physical damage, dirt, fire, none of the above. And third, where should the air seal be located around fenestration? All the way around the frame at the interior edge, top and sides around the frame at the exterior edge, all the way around the frame at the exterior edge, top and sides around the frame at the interior edge, and there isn't an air seal required. Again, we're talking about the air seal on this one.
So far, we haven't had any questions come in. Again, if you do have questions, please enter them in that Q&A window. We'll be glad to answer them for you. Okay, got a couple more answers coming into our poll question. Okay, looks like everyone is answered. That's going to, so we'll share those results.
All right. Can continuous insulation have thermal bridges other than fasteners or service openings? The correct answer is no. By definition, fasteners and service openings are the only thermal bridges continuous insulation allows for. All right. Second, what does insulation need protection against? Compression, yes. Wind, not really. That's not one of the requirements. Ultraviolet, yes. Physical damage, yes. Dirt, no. And fire, yes. So few people picked up on that, but a few others. So where should the air seal be located around fenestration? All the way around the frame at the interior edge is correct. So good third of the people got that. So yes, the air seal goes to the inside, the water seal goes to the outside. So all right, overall pretty good. With that, I'll turn it over to my colleague, take us through plumbing and mechanical.
Okay, thank you, Ryan. So first, we're going to cover the plumbing rough-in inspection requirements. So for the plumbing rough-in, you need to be checking types of insulation on hot water piping and any refrigeration piping within the building, corresponding R value for that insulation, that insulation is protected, and that the proper controls are installed for those plumbing systems. One of the things we like to call out as best practice for plumbing insulation, there are different types. No matter what type you use, mitered corners or formed corners are good to use on that insulation. This provides some additional benefits in that your thickness is maintained for that insulation, so you're maintaining full R value. For any refrigeration or cold water piping, that's going to reduce your risk of condensation as well. It's going to relieve stress on that insulation so that seams can't split apart. It's going to reduce the potential for long-term damage to that insulation due to those stresses of being compressed and stretched. And so we do like to highly recommend formed corners or mitered cuts in that insulation anywhere you've got bends in your piping. There are many different types. You've got these expanded foams, EPDMs, fiberglass. So there are multiple different types of insulation. What is important is to get the proper thickness to get your proper R value as required by the code. Um, for hot water piping, R3 insulation is required. So for this particular type of insulation, that's going to be their half-inch wall, but there are multiple thicknesses available for plumbing insulations. So make sure that you're getting what you need to meet your requirements. Another big component is protection of any insulation that may be outside the envelope of the building where it's exposed to weather, UV, or mechanical damage. There are wraps available for insulation that can be those wraps are required by code to be removable for maintenance purposes. So you could not use a tape on that insulation as protective coating. It must be a removable shell, or you can see here it's a membrane that has a Velcro fixture on it. Um, that protection is important for prevent dry rotting of that insulation and early degradation that will reduce its R value and expose that plumbing to damage, condensation risk, and other issues. Did get a note to speak louder. I will try to do so. Another thing for plumbing inspection is controls. If you've got hot water circulation systems in your residential facility, then you'll need to have proper controls installed for those circulation systems. There are two types, demand circulation system and a continuous circulation system. For both of those systems, the code requires some sort of demand sensor um, to detect when hot water is being called for in the building. Um, what we're noting here is you could not have just a timer on a pump system mounted to that water system because it's not indicating when there's a demand in that residential facility. So you would have to have a flow sensor mounted to the cold tap inlet to the hot water tank. It is the best place to install that to detect when hot water is being called for in the building, and that tank gets refilled then through that cold tap inlet. Um, if you were to put a flow sensor on the hot tap, whenever the pump turns on to circulate water, it's going to detect that flow and then stay on because flow is being continuously detected. So be sure that that flow sensor is properly located on the inlet on the cold water side of that hot water heater. Um, and again, noting that you could not use a timer to meet that demand control component of the code. It has to be a flow sensor, some kind of sensor at the fixture unit in the building to indicate that there is a demand for hot water. For systems serving multiple units, more common in larger apartment complexes than it is in single family or townhome type situations. But if you have systems, either hot water, service water, or HVAC that are serving multiple units, it is important to know that you will then be directed to the commercial provisions of the energy code for those systems instead of the residential sections. So important to know that those requirements change if you have multiple units being served. Moving on to the mechanical rough-in inspection. Things that are called out to be inspected. The HVAC equipment type has to match the design. The size, output capacity of that system needs to match the design as well, especially since for residential you're required to have manual J load calculation and then a manual S sizing calculation. It's important that the size that's installed matches those calculated designs for the HVAC system. The system must meet required efficiency from the code. Controls must be in place and functioning. System has to be insulated properly if you've got ductwork running outside the thermal envelope of the building. Any refrigeration piping also needs to be insulated, as we touched on in the plumbing section. That insulation has to have the proper R value. System air leakage control must be in place, so inspections for duct sealing, um, that the installation or duct installation has been tested for air leakage, and that report is available. Um, if you've got an ERV system or a supply side fresh air system, that the dampers that are connected to those systems are installed properly and working properly. And if you've got a whole house ventilation fan, that fan meets minimum fan efficiency requirements. So to get into those in detail, the equipment type, very important. Air conditioner or heat pump is it electric heat versus a gas system, or if you've got a heat pump with supplemental heating, is it a gas backup heating or electric backup heating? Making sure that those installed systems match what's in the plan. If not, that the loads haven't changed in any way that are going to affect that system performance, and that whatever system's installed meets the minimum federal requirements for system efficiency, which is the requirement for the energy code in residential buildings. One thing to be aware of with heat pump systems is that commissioning those installed in the building is just a little bit more involved, since you've got that reversing valve in the system to make sure that that is working properly as the system is installed in the building. Next thing that we want to look at is, does that installed equipment meet the design loads of the building? If it's significantly larger or significantly smaller than the design, you're going to have issues with comfort in the building. If it's largely oversized, the system's going to have issues with short cycling, which will increase wear and tear on the equipment and decrease its overall efficiency. When you're calculating loads for the building, it's not likely that your building load is going to be exactly, in this instance, 80,000 BTUs per hour. It's probably going to be, for this building, was probably in the upper 70,000 BTU per hour range. But when you're picking equipment, you're essentially picking the closest size that's going to meet those loads. So it's the next largest size that's going to meet the loads for that facility or building. But if that system is significantly smaller, for any reason a smaller unit is picked, then most likely you're going to have comfort issues where that system's not going to be able to meet the loads in the building during extreme temperatures. And another note for oversizing, if that's on your AC system, you're going to have a significant problem with controlling humidity in the building. It's important for humidity control that a system be able to run for more than, if I remember right, about 15 to 20 minutes in order to get adequate dehumidification for a space. So proper sizing helps ensure that that cycle time is not so short that dehumidification does not occur. Equipment efficiency is the next thing to check once you verify that the size is correct. Usually efficiency and capacity are listed on these energy guide stickers that are stuck on the units. On the left side of the screen, we've got an energy guide sticker for an AC unit denoting its SEER efficiency. And on the right, we've got a gas furnace that has its efficiency denoted. So does that efficiency match the design? If it's slightly higher efficiency, all the better, because you're going to save your client more money. If it's below design, is it still compliant with the code? If it is, it may be able to be approved. If not, it may be affecting whether the system can meet the load in the building or not. So you want to make sure higher than the design is better, especially if you're designing to meet the code minimum requirements for efficiency. Next thing, HVAC required controls. Are they installed? Are they working properly? Are all the controls that are needed for your design system in place? If you've got supply side mechanical ventilation, you're going to have most likely a damper on a fresh air duct that's coming into the return side of the system. That damper needs to be connected to the fan so that it only opens when the fan is on to prevent drafts coming in from outside uncontrolled. Are your temperature controls in place, such as a programmable thermostat or a smart thermostat? Is that working properly? Is it scheduled properly to meet the code requirements? and then runtime controls for ventilation if used. So again, if you've got supply side ventilation coming into the air handler, or sorry, return side fresh air ventilation coming into the air handler, that air handler fan is going to need to have a timer on it to ensure that you're getting adequate fresh air ventilation, especially during mild times of the year when that furnace wouldn't normally cycle on and off very much. It's important to have that timer on there so that if windows are closed in the building, you're ensured that you're getting the fresh air requirements that the code requires. And if you've got an ERV or HRV that's not running continuously, you've opted to run it a portion of the time, then again, those time controls need to be in place to ensure that you're getting the required ventilation in your building. So once you've inspected all the controls and the systems in place, then you go out to the distribution system. You want to check that your duct insulation is in place, where that ductwork is outside the thermal envelope of the building. One thing to be aware of is if that duct insulation is in the attic, it's going to be a slightly higher requirement than if it's in a crawl space or other unconditioned portion of the building, such as maybe a bonus room floor over a garage. What we're noting here is this duct wrap is an R8 duct wrap. So does that meet the design value? Is that what's required for the location of the ductwork and the size of the ductwork? Also checking the ductwork for proper air sealing. Have all the seams and joints been coated properly with an appropriate duct mastic or UL rated sealing tape? And has that duct testing been completed yet? Usually that duct test is done along with blower door testing and provided to the code official in a separate report. But it's probably a good practice to have that report on site as well at the building. Duct leakage and air leakage testing is required to be reported on the energy compliance sticker that goes in the mechanical space. So that's one way that you could have that information on site for an inspection as well. But usually these inspections are being done before that final blower door and duct leakage test is done. So the code official is probably going to have a couple of different site visits to ensure that the mechanical system is all properly installed and air sealed, and then they'll get that air sealing report separately instead of looking for that on site. For your HVAC system controls, is it a programmable thermostat that's installed? Does that thermostat have a proper schedule set up in it? It must have at least 7 different daily programs. So a 511 thermostat would not comply, or a 52 thermostat where you've got weekday settings and then different weekend settings. There must be 7 individual day settings available on that thermostat. And is it properly set up? The initial set points for temperature must meet settings that are listed in the energy code. 74 degrees for the cooling set point, 72 degrees for the heating set point, if I remember correctly. And initial settings for any learning thermostats must also be set up that way. They can be changed by the occupant afterwards, but for code compliance purposes, those initial settings must be in place and must be documented. HVAC system dampers. Are those dampers installed and adjustable? There's a couple of different places where you'll see dampers. Again, as I noted before, if you've got a supply ventilation system where you're bringing in fresh air, it's coming into the return and being supplied to the air handler, and you're generating positive pressure in the building. If you've got that positive pressure ventilation system, there's going to be a control damper on the ductwork that's bringing in that outside air. There's also probably going to be dampers for airflow adjustment and balancing on the supply side of the system. You need to make sure that those are properly set and they're not fully closed where any part of the house isn't going to get proper airflow. So making sure that those are properly set and have been balanced to get airflow throughout the house. Your ventilation system controls. It's very common for us to see exhaust only negative pressure ventilation for residential homes. Um, Typically what we see is a centrally located bathroom fan or hallway fan that's drawing out exhaust, and it'll have a dial set up in it, sort of like what you see on the left side of the screen here, where you can set up how many minutes per hour it's going to run. Um, you can set it to run up continuously or any number of minutes per hour. Um, you can set up what the airflow rate for that fan will be um, on the supply side, and also on, in this case, on the exhaust side and supply side. So this would be for like an HRV type situation. But we also see bathroom exhaust fans where you can have similar settings. Um, for whole house ventilation systems, you must also have a control that is available so that the occupants know whether the system is operating or not. So you can see a couple of examples here of indicators for whole house ventilation fans, whether they're on or operating on the right side of the screen. You also want to verify whether this ventilation strategy matches what was in the plans. If you've got an ERV or HRV system designed for the house and then a exhaust only or supply only ventilation system was installed, that's going to change the loads in the house a little bit. Um, and so uh, your system sizing may be affected by such a design change. So it's important to make note that your ventilation system matches the design ventilation. If you're going with a supply side ventilation system, um, you want the building to be slightly positively pressurized, not overly so. Same thing for an exhaust air system. So making sure that the design airflow rates are what are set up on those fans so that you're not going to have issues with drafts in the house due to pressurization issues. If you've got a fan set up for whole house ventilation, it does have to meet minimum efficiency requirements in the indicated table on screen here. Um, so it's important to check if you've got a furnace that is operating as your whole house ventilation system, as in the case of a positive pressure ventilation setup, then that HVAC motor needs to be an electrically commutated motor. That is the only requirement. If you've got an attic fan or an exhaust fan system separate from the central HVAC system that is providing that whole house ventilation, um, then it needs to meet these minimum fan efficiency requirements listed in table R105.2.1. Um, you can see blower performance changes based on the static pressure across that fan. So it's important to check and make sure that that fan static pressure um, matches the airflow requirement. It's not uncommon to see in installations where you've got kinked ductwork due to installation practices that will reduce that airflow and thus not meet the intended design. So important to check and make sure that that is correct during that site inspection. Before we move on to our next section, we do have another set of poll questions, which I will now launch. Our first question are what are the benefits of using mitered or pre-made bends for piping insulation? Does that help maintain the insulation thickness and R value? Does it reduce stress on the pipe joints and seams? Does it reduce condensation potential? Does it provide UV protection? So there's multiple choice answer there. And for a house with a positive ventilation only, what items need to be checked on the HVAC system? An exhaust fan interlock, that there's an outside damper on the return side of the ductwork, and a fan timer set to run that fan at least 25% of each hour to ensure adequate ventilation. And again, we haven't had any questions come into our Q&A box, but if you do have any questions, please feel free to enter them there and we will answer them. few more seconds on this poll question. We'll share the results. Okay, looks like everyone's answered who will. So our first question, what are the benefits for using that mitered or pre-made bends for piping insulation? It does help maintain insulation thickness and R value. It does help reduce the stress on pipe joints and seams, and it does reduce the risk of condensation potential. UV protection is provided by the wrap, not the mitered joints on the corners. So it looks like most people got at least the first part of that correct. The two other parts are kind of related to maintaining that R value. For whole house with ventilation on positive only, oh, I forgot to share the results. There we go. For positive ventilation only, what items need to be checked on the HVAC system? There will not be an exhaust fan interlock since you are doing positive ventilation, but you will have that outside air damper, and you will have a fan timer on that HVAC unit to ensure that you're bringing in that outside air as required. So it looks like most people got that correct as well. And I will turn it over to Ryan to go over the final inspection requirements.
Well, thank you, Sean. So during final inspection, this gives the inspector the opportunity to check any remaining building systems, equipment, anything that was deferred from an earlier inspection. Some of those Sean mentioned earlier. This may even be things like duct testing. So as far as blower door testing, this is typically the stage when we'll see this occur if it had not occurred earlier. Doing blower door testing is required for residential construction for the state of Illinois. The air leakage rate is not to exceed 4 air changes per hour, but again, this depends on what was per the design. Something to be aware of, and we kind of allude to this throughout this presentation, is we want to make sure that we are matching our design, particularly because not all projects use the prescriptive path. In this case, the prescriptive path specifies 4 air changes per hour. Under a performance path, that could be used as something else. It is possible that 4.5 air changes per hour was done under the prescriptive or under the performance path, and to account for that leakier air envelope, some other trade-off was made. So that's where any project that is using one of the performance paths throughout all these inspections is verifying not only that they meet the code, but verifying that they meet the actual design, because the design will be the reference for that. Not surprisingly, for blower doors, the code officials may require that these are conducted by an approved third party. Don't necessarily may not be the wisest thing to let the builder test his own building to say, did he pass his own test? And so one of the important things here is that this test has to be done after all of the penetrations. So that includes all the plumbing, electrical, any HVAC penetrations. After that is when you do this. Now, it's not uncommon to see for high performance buildings that are really going for some high air tightness standards. We may see that they test their building a few different times. They may test their building initially after the envelope is complete, but before the penetrations are made, and then test it again after the penetrations are made to see how much degradation there is, and to verify that the envelope was tight beforehand. So this is normally observed more generally, as noted, during high performance buildings. Now for multifamily housing, so low-rise multifamily, this Illinois presently allows for a alternative methodology for testing rather than doing it based on air changes per hour. This could be a cubic feet per minute per enclosure area. So all 6 sides of the, or more than 6, but if I'm just building a rectangular square box, all 6 sides accounted for. This is a little bit more accurate of a test than the air changes per hour because this is really testing how good is the enclosure area. So this allows for particularly smaller buildings to be able to meet the test, whereas a volumetric air changes per hour is a much harder test. Also, if you have more than 7 units, there is the ability to use a sampling protocol for that testing. Also, during the final inspection, as noted, we're going to check all remaining building systems. So this could be fan efficiency requirements for ERVs, HRVs, kitchen exhaust hoods, bathroom fans, and the like. Also noting here, if you do have kitchen exhaust hoods that are 400 cubic foot or larger than 400 cubic foot per minute, then you have to have a dedicated makeup air unit for that, which again, that's some additional equipment that has to be commissioned and tested. So also verifying and checking any remaining equipment controls. So this could be things such as ventilation systems. This may also include your dampers for zoning. Some of these controls are humidity based or time based, or many other methods. So going through and verifying any and all remaining controls that were not tested previously, and I may go back and spot check a few to verify that they're still functioning correctly. And one of the final checks generally is are the required number of high efficacy fixtures present. So here we see 2 different fixtures. The code calls out that at least 90% have to contain high efficacy lighting sources, and we're depicting here 2 fixtures. So even though the fixture on the left contains 3 lamps or bulbs, it still counts as a single fixture. So that's something that leads to a little bit of confusion at some time. This is the number of fixtures, not the number of lamps total. So something else that may also be checked, if the duct sealing wasn't checked earlier, you might check that, including commonly missed is the longitudinal seam. So the one that runs along the whole ductwork, not just at the joints. So with that, just want to remind everyone that those who are in attendance throughout today, we will go ahead and be sending out certificates of attendance. If you do need your AIA or ICC credits, go ahead and reply back to that email with your member number. And we'll go ahead and get those recorded for you. Recording of today's presentation, along with the slides, will also be posted to our website, sedac.org/energy-code. So with that, not sure if we have any questions that may have come in. I do want to thank everyone for attending today.
Looks like no questions have come in, so we will wrap up our presentation. Thank you all for attending, and we hope to see you at our future presentations.